And here's the second experiment. I believe it's labeled Part B on our lab handout. And the coil over there on the left, it's exactly the same as the coil for the experiment in Part A, with the magnet hooked up to a voltage sensor going to Logger Pro. But what I've done here on the right is I've got a second identical coil, and it's hooked up, if you look, to a switch with a 9-volt battery. The 9-volt battery is going to one side of the coil, and then the switch here is going to the other side of the coil. And so when I close the switch, I should be able to turn on current to the second coil. I'll put it on top, and it'll create a magnetic field. That magnetic field should induce a change in the magnetic field of the coil on the left, magnetic flux seen by the coil on the left, and you should see a voltage spike as I change the voltage in the coil, which I'll call the primary coil, with the one I have the switch and the battery hooked up to. Okay, and so I'm going to take this coil that has the battery hooked up to it with the switch, and I'm going to set it right on top of the original coil with the voltmeter hooked up to it. Excuse me. And I'm going to bring this over here, and it shouldn't take but a second, and I'm going to hit collect again and start taking data, and I'll shut the switch, and you see a big spike, and I'll open the switch, and you see a second spike. And I'll auto scale those, move the coil out of the way for you. And what you should notice, when I close the switch, I got a voltage spike down there. I'm not sure what this noise was right here, but then when I opened the spike, it came up, and I'll blow that up for you. This little piece down here, when it came back down, it actually overshot and came out. And let me blow up that region for you. It's right around 6 seconds into the experiment. And so let's go from like 5.5 seconds out to, oh, I don't know, 6.5 seconds. And I can even blow it up a little more. Let's go, it's between 5.9 and 6.0. 5.9 and 6.0. And a little bit of noise, but you can see initially when I opened the switch, it went up, and it actually kind of jiggled a little bit as the switch made contact, and then as it came back down, it overshot until it finally went to 0. But notice, while the switch was fully shut and the magnetic field was constant, there was no electromotive force. And then after I opened the switch, and of course there was no magnetic field, it was also constant at 0, and so that's how the experiment goes.